The days of typing out endless instructions and hoping the AI guesses your intent are over. In 2026, development has moved past prompt engineering. We are now in the era of harness engineering. This means designing the rules, tools, and memory that surround and control the AI model. This diagram maps the architecture of a 2026 setup. The agent is a combination of the model and the harness. In this environment, the harness is the dominant variable. Claude Code is incredibly capable, but its output quality is no longer limited by how smart the underlying model is. It is limited by the quality of the environment you build around it. Refining this environment is what separates a productive session from one plagued by hallucinations and off-track code. Recently, Anthropic flooded the zone with updates. We now have 1 million token contexts, agent teams emerge, and lifecycle hooks, all operating natively inside the terminal. The community responded by building massive wrappers. The framework Everything Claude Code exploded to over 50,000 stars, offering pre-packaged automation for almost every conceivable workflow. This leaves senior developers with a choice. Do you blindly install these massive third-party frameworks and run multi-agent teams for every pull request, or do you build your own environment from scratch? Adopting everything at once carries serious risks. Your API costs can easily skyrocket overnight, and your development environment can quickly turn into a black box where you don't actually know how the AI is making decisions. This chart shows how they are going to evaluate these new tools. We are running them through a strict return on investment framework, comparing the effort required to set them up against the actual impact on your workflow to protect your time and your budget. The foundation of a strong harness relies on Claude's native tools, creating custom skill.md files and configuring lifecycle hooks. Setting this up requires you to sit down and write clear, markdown-based operational manuals, detailing exactly how your specific project workflows operate. This visual shows where skills and hooks land on our matrix. Once configured, the AI automatically runs linting, tests, and formatting every time you save. You invest upfront setup and permanently eliminate the need to manually instruct the AI. This foundational layer is required. If you skip mapping out your basic rules, any advanced tools you layer on top will simply waste tokens trying to guess your intent. With the release of Opus 4.6, Anthropic introduced agent teams. This is a completely different architecture from the older, traditional subagent model. A traditional subagent executes serially. The main agent delegates a specific task, waits, and receives only the final output. The token usage remains highly efficient. This diagram illustrates the difference. On the right, agent teams run multiple AI instances in parallel. Each maintains an independent context window, communicating directly to solve problems. But that parallel processing comes at a steep price, multiplying token consumption by 5 to 7 times. Subagents are best deployed for routine tasks that have a clear, objective outcome, where you only care about the final result. Agent teams should be reserved for highly complex, multifaceted tasks, like an architectural refactor, where you need the AI instances to debate trade-offs and provide multiple perspectives. Deploying agent teams for everyday coding tasks will drain your API budget in a matter of hours. Strategic routing of your tasks is the only way to keep costs sustainable. This brings us to the immense allure of third-party frameworks, like Everything Claude Code. They offer instant access to 57 commands, continuous learning loops, and language-specific rules. Looking at our matrix, a full installation seems to drop right into the ideal zone, a zero-effort harness installed in seconds. But note the warning symbol. The hidden cost is complexity. The densely layered environment makes troubleshooting broken workflows or conflicts nearly impossible. This is the paradox of the black box. By adopting a massive, pre-built harness to control the AI, you inadvertently create a system that you no longer understand or control. Adopting these massive frameworks wholesale sacrifices long-term ownership of your development environment. You trade deep comprehension for the illusion of immediate speed. Treat giant frameworks as reference textbooks, not as plug-and-play installations. Instead of installing the whole package, use a cherry-picking method. Read through the repository and manually extract only the elements your project needs. You might grab a specific linting rule, but intentionally leave the 50 bloated / commands behind. This surgical approach guarantees every piece of your harness serves a direct purpose, keeping your environment lightweight. When tight deadlines and unpredictable bugs appear, a lightweight, understood harness will always outperform a bloated, imported system. To build a cost-effective Claude Code environment for 2026, follow this 4-step roadmap. This chart maps the process. Step 1. Start with a strict, minimalist Claude.md file defining core boundaries. Step 2. Write custom skill.md files for your most repetitive tasks, guaranteeing immediate returns. Step 3. Strategically extract advanced features from frameworks only when you hit a proven limitation. Step 4. Keep agent teams locked away, deploying them exclusively for high-stakes architectural debates. In the era of autonomous AI, your true job is no longer writing the code. It is relentlessly optimizing the environment